All right, welcome back. Today, we're diving into a topic that is, and I'm not exaggerating here, a total career definer for anyone who touches data. It's the secret sauce, the magic trick that makes applications feel snappy and responsive instead of slow and clunky. We're talking about database indexing, and trust me, it all starts with a really simple idea.
To really get this, let's just imagine for a second. You've got this enormous storybook, maybe thousands of pages long, and your job is to find every single time the word dragon appears. So how are you going to do it?
Well, option one, you could start at page 1 and just read the entire thing, page by painful page. That's going to take forever, right? It's slow, it's inefficient. Or you could flip to the back, look for the index, find the word dragon, and get a perfect list of every single page number it's on. That's fast, that's smart. That index in the back of the book, that is exactly what a database index does for your data. So here's our game plan. First, we're going to talk about why this speed is so critical. Then, we'll take a quick tour of the most common kinds of indexes out there. After that, we'll get into the really smart strategies for using them effectively. And finally, we'll talk about the indexer's dilemma. Yeah, the hidden costs that you got to know about.
Okay, let's kick it off with Section 1, the need for speed. Let's really get to the bottom of the problem indices are built to solve. It's all about turning a super long walk into an amazing shortcut.
So take a look at this. This is a totally standard SQL query. We're just asking our database, hey, can you find the user with this specific email? Now, if that users table has millions of rows and no index, the database has no choice. It literally has to start at the very first row and read every single row, checking the email until it finds the one it's looking for. We call that a full table scan, and it's just as slow as it sounds.
And this slide really nails the difference. Without an index, the performance is what we call ON. All that means is the more rows you have, the longer it takes. Simple as that. But with an index, the performance becomes O log n. Now that might sound technical, but it basically means the query time barely increases, even if you go from 1,000 rows to 1 billion rows. It's not just a little better, it's a night and day difference. It is literally the shortcut.
So let's put a pin in it with a formal definition. A database index is just a special data structure that lets the database find stuff really, really fast. But, and this is a big but, it's a trade-off. You're giving up a little bit of disk space and making your writes a tiny bit slower in exchange for making your reads massively faster.
Which brings us right to Section 2. Because, as you might have guessed, not all indexes are the same. It's not a one-size-fits-all situation. So let's take a quick tour so you know you're always picking the right tool for the job.
First up, the B-tree index. This is the default, the workhorse, the one you're going to use probably 95% of the time. It's basically a sorted tree, which makes it awesome for finding exact matches, but also for things like range queries, find all sales from last month, and for sorting your results. When in doubt, you're probably creating a B-tree. Now for something a bit more specialized, the Brin index. This thing is so clever. Instead of keeping track of every single row, it just remembers the minimum and maximum value for huge chunks of your table. Back to our book analogy, this is like a table of contents that just says, dragons are talked about in chapter 5. It doesn't tell you the page, but it narrows it down a ton. It's super tiny and amazing for huge tables where the data is naturally ordered, like by a timestamp.
And finally, let's talk about how they're stored. A clustered index actually reorders the data in the table on the disk. It's like the book itself is physically sorted by topic. You can only sort a book one way, right? Which is why you can only have one clustered index. A non-clustered index, on the other hand, is our classic back-of-the-book index. It's a totally separate thing that just points to the right page. And just like a book can have multiple indexes, you can have many of these on a table.
Okay, Section 3. Now that we know the basic building blocks, let's get into the fun part, the strategy. Because it turns out, it's not just what you index, it's how you do it that really matters.
This leads us to a super important idea, the composite index, also known as a multi-column index. All we're doing here is creating a single index on 2 columns at the same time, city and then order date. This is great for queries that need to filter by both, but there's a catch. A big one. And here's the catch. This might be the single most important rule to remember about these things. In a composite index, the order you list the columns in is everything. It literally determines if the index can be used or not.
So, because we created our index on city order date, any query that uses that first column, city, can take advantage of it. So searching for a city alone works perfectly. Searching for a city and a date also works perfectly. The database finds all the Delhi entries first, then sifts through that much smaller group by date.
But now look at this. If your query only searches by order date,
It's skipping the first column in our index, and because of that, the database can't use it. The data isn't sorted by date first, it's sorted by city. This query would be just as slow as if we had no index at all. Getting this order right is absolutely critical. Now for a real pro-level move, the covering index. This is where your index contains every single column that your query needs to answer the question. So, if the database can get everything it needs just by looking at the index, it never has to go and read the main table data at all. This is called an index-only scan, and it is just ridiculously, unbelievably fast.
And all this talk of speed and power leads us perfectly into our final section, the indexer's dilemma. Because after hearing all the good stuff, you might be tempted to just slap indexes on everything. And that is when good intentions can go very, very wrong.
I mean, it's a fair question, isn't it? If indexes make our queries so much faster, why not just put one on every single column we have? More speed is better, right?
Well, here's the catch. Indexes aren't free. Not at all. For every single write you make, every insert, update, or delete, the database now has extra work to do, because it has to update every single index on that table too. Too many indexes and your write performance can just fall off a cliff. Plus, they take up disk space, they take up memory, and they need to be maintained. So this all leads to the professional rule of thumb. You should index for the queries you actually run all the time, not for the queries you might run someday. Be strategic, look at your slow query logs, see which queries are actually causing pain in production, and build smart indexes to solve those specific problems. So here's a simple mental model you can use every single time. Before you type create index, just ask yourself these 4 questions. 1. What are my most frequent, most important queries? 2. What columns are they actually filtering on? The stuff in the where, join, and order by. 3. Is my application doing mostly reads or mostly writes? And 4. Can I be clever and make one composite index that actually helps out 2 or 3 different queries? Answering those questions will help you sidestep all these classic mistakes. You know, indexing everything, we just saw why that's a bad idea. Indexing columns with low selectivity, like a gender column with only a few options. That doesn't really narrow down the search, so the database might just ignore the index anyway. Getting that column order wrong in a composite index, we saw how that makes it useless. And the big one, just plain forgetting about that write-cost trade-off.
And really, it all comes down to this one final thought. Writing good SQL is all about asking the right questions of your data. But creating good indexes, that's what makes sure you get the answers back fast. Mastering that relationship, that balance, is what separates the good from the great when you're working with data.